some of the features that are associated with groundwater. फर्स्ट ऑफ दैम इज स्प्रिंग्स स्प्रिंग जिसको आप लोकल लैंग्वेज में चश्मा कहते हैं बेसिकली कैसे फॉर्म होते हैं कि जैसे ही वाटर टेबल आपका उस एरिया का वाटर टेबल जैसे कल हमने बात की थी कि जो टोपोग्राफी है इट विल डिफाइन द ग्राउंड वाटर एंड ग्राउंड वाटर शेप will be dependent on the local topography of the area. Sometimes some of these places where we have the mountainous areas intersected with the plain areas, and on those locations the groundwater sometimes it intersects the earth surface, and the groundwater comes to the surface. We call these features as springs or natural springs, and or maybe it can be result of perched water table. Perched water table is a water table in which we have it is just like a disconnected water table. You can say that maybe disconnected from the main water table, or maybe it's a remnant of an old water table. So you can see here we have the main water table here. You can see the blue color, and you can also notice there is one stream that is cutting this valley, and you can see that it is a very perfect V-shaped valley. That is characteristic feature of water. And then we have, this is the aquitard. Aquitard, as we said yesterday, is a clay layer that is mostly present underneath, or sometimes it can also be present above the water table, and sometimes it forms a lens shaped water table. We call it as perched water table. The perched water table look like something like this, like a lens shaped, and mostly in some areas like the mountainous areas we have the perched water table, and that is mainly disconnected with the main water table. And sometime when this water table it intersects the topography, you can see that this is the topography of the area and this is the line of intersection, and then you have the formation of these natural springs, and you can see that this natural spring is ultimately joining the mainstream, and then mainly this mainstream will form in the river, and then river they fall into the seas and oceans. A beautiful spring, fresh water supply, and most of these natural springs like in Naran, Kagan, and Upper Himalayas, where normally you go for spend your summer vacations, are the locations where you can find beautiful natural uh, waters coming from underneath earth to the surface in the form of springs. Well, there are some springs that are hot springs, and they are warmer in temperature, like 6 to 9 degrees warmer than the local temperature of that locality. And maybe you have seen that Tata Pani in this is a location in Azad Kashmir, and I think there is a location called Garam Chashma in Chitral. If you guys had a chance to go there, maybe in future, you can see that fresh water, hot water, and people normally go there and then they try to boil their eggs and cook some stuff there in those hot springs. Actually, what happens, you guys have studied igneous rocks, and you know igneous rocks are well heated, and sometimes the magma chamber is still active under the surface of earth, and when water goes down, and the temperature underneath from the magma chamber, it makes the water again towards the surface, or move the water towards the surface of earth, and as a result we have the formation of these type of springs. We call them hot springs. However, these hot springs are very important if you consider the energy supplies of the future, like for example geothermal energy. Maybe you guys have listened the name, and actually geothermal energy is the future of energy equation in the world. And if you guys want to do a further studies, it is also a very vibrant subject. So I suggest you guys search geothermal energy and just try to read a little bit about it. It's very interesting subject, and it is very promising subject. In Japan and in some European countries, they use this heat or this stream to warm their houses, and also to perform other heating operations in colder climates. You can see here a hot spring, and you can see that the bubbles coming in. These bubbles are a result of the high temperature. Maybe underneath subsurface, we have a magma chamber that mocks these springs and make them hotter, so that you can still see the geysers. The difference between hot spring and geyser is that in geysers you have eruption of water, and these are can be considered as intermittent hot springs. Normally they flow like hot spring, but sometimes you have water erupting like a hot volcano and moving around the areas. And they normally occur where extensive underground chambers exist within hot igneous rocks. The groundwater heats, expands, and changes to steam, and as a result, it erupts. So these geysers are also very important in terms of understanding the internal heat of the earth, and also to be used uh, as a medium for designing the geothermal energy in an area where geysers and hot springs are present. We can understand that those areas are very good and promising for geothermal energy, and you can use those areas and analyze those areas. You can see here some of the locations of hot springs and geysers in the United States of America. You can see that on the eastern part we have some, but the most interesting part is the western United States, where we have a lot of these hot springs and geysers that are present, and they can be used for. Now come to our country, Pakistan. We have few of these hot springs located and in different parts of of our country, and you can see that some of them are located in Sindh province and the western uh, border of the Punjab province with the Khyber Pakhtunkhwa, and then the Gilgit-Baltistan region actually has a lot of these geothermal higher degrees uh, hot springs and geysers. Okay. And based on this map, you can design your study. If you want to do masters or PhD, you can collect the data in terms of the temperature, and then you can plot that data and try to understand. Like one of my friend, he collected some samples from Chitral, and he tried to understand the geothermal energy. He is working on master's project from China University of Geosciences. He recently finished his thesis. Similarly, you can see that Kohe Sultan, this is the area in Chaghi province, Chaghi district in Balochistan province, and you can see that it also has the pocket of geothermal system in the western part of the our country, and those areas are very interesting, and they can supply the future energy needs of our country. And as you see, the population is growing, so we need more and more these type of alternatives for energy in energy deficient environment. You can see that a beautiful geyser, and see the power, the force with which water is erupting. So these are called the hot geysers that are very interesting, and sometimes some people they go and visit these places, and they become tourist attraction, just like the one of the famous old faithful geyser in Yellowstone National Park in United States. And you see people just go there to see water erupting from underneath, and stuff like that. Or there are some other features that are associated with groundwater. Normally, we make wells to get the water supply and to penetrate the water table. Uh, Once you penetrate the water table, you start production of water, and as a result, when you are drawing more and more water, the water table become low in that area. As we have discussed some example from Quetta city, where the water level is dropping very fast. And there is another thing that is interesting phenomena. We call it cone of depression. Just like once you pump the water out of the water table. So this is the water table, and this is the zone of aeration where we have water, but it is not fully filled, as this is the zone of saturation. And you see, if we have a deep well and we do very heavy pumping just to supply the agriculture, or maybe we supply it to form a new develop a new area, just like the development authorities in different parts of the world. So you can see that as a result of heavy pumping, these wells that are located shallow become dry, and these wells that are located deep, they make the water table low. And you can see that the water, because it is in the pore, so it takes some time to recover this depression. That's why normally in heavy pumping tube wells, they give time to water to recover, so that the water recovers its level, and after that you start pumping again. That's why understanding and using the water efficiently is very important. And if we are wasting those resources, it will cause us greater damage in future. Okay, there are some wells, we call them artesian wells. Artesian wells are those in which groundwater, it comes to the surface of earth without any pumping, without any artificial design. It just starts flowing to the surface of earth. Or there can be two types of artesian wells: non-flowing and flowing. Non-flowing is that in which the pressure surface is below ground level. You need extra pumps to flow this well. However, flowing is that in which the surface pressure is so much that the water flows by its own self. However, we see here a figure of this artesian well. We have you can see that these are the rocks, or these are the layers that are present in the mountainous areas. And if there is heavy rainfall in these areas, that rainfall actually puts more and more water in the reservoir. And you can see that this is a confined aquifer. That means it has more impermeable or non-porous layers, those layers that cannot hold water. And as a result, it just like a sandwich. This porous layer, this layer having water, is just like sandwich between two non-watery layers. So when you put a well here, that well actually comes into contact with the aquifer, and you can see that the artesian well, the water rises and maintains its level. We can call it like the where in the subsurface we call it as a water table. And you can see that if the well reaches below the, if the topography reaches below the mountainous well, we can have the artesian well that flows itself, so you don't need any extra effort to produce well from here. Oh, there's another illustration that you can see that this is the recharge area. That's why if you have heavy rainfall in the mountainous areas, chances are there that your soil and your rocks are pervious. And pervious means that water can infiltrate, and as a result, it continues recharging. So that's why we always suggest that we need more recharging area for our aquifers in our country, so that if there is more recharging, then the chances of having longevity of the water reservoirs increases. Okay, so there are some problems associated with groundwater withdrawal. If you draw heavy groundwater from the subsurface, then chances are there that the water withdrawal may increase the subsidence. Like for example, if you draw maximum water from this reservoir, then this layer will subside. ये एरिया जो है ये बैठ जाएगा, जिसको आप उर्दू में कह सकते हैं कि ये एरिया जो है, इसके अंदर ये जो पूरा एरिया है, like this particular area can have subsidence, and as a result of subsidence you can have a problem in designing your buildings. So this problem exists in the city of Quetta, where we have more withdrawal, and as a result of that, the city is sinking. इट मीन्स जो एरिया है, मुख्तलिफ एरियाज हैं वहाँ पे जो रेजरवायर के ऊपर एरियाज एग्जिस्ट करते हैं, those areas. Another example is San Juan in the Valley of California. There is another one example here is saltwater contamination. As you guys have seen yourself in the city of Sargodha, that we have the saltwater contamination, and this is the result of salt water, and mostly it occurs in coastal areas, but because of the presence of salt range formation underneath the and effect of Kirana Hills, the area of the city has contaminated water. Similarly, the cities of Kasur and other cities like coastal areas in Pakistan, because of the seawater moving in, we have the problem of salt water contamination. So you can see here, salt also has groundwater, and this is the fresh water, fresh groundwater. And if you increase the pumping, as a result of extensive pumping, this water level will decrease, and the salt groundwater will replace it. And one day will come when most of the fresh water is gone, and you are just producing the salt groundwater. So that's why understanding the groundwater, the fresh groundwater, is vital and important, and it can guide you to save your resources. Okay, there is another contamination, the sewage that we have in our areas, and sometimes it has openings, and the old pipes, they sometimes they are fractured and they are gone, and as a result of that the groundwater is contaminated by deep sewage pipes, and sometimes they are contaminated. There are other contamination as well: highway salt, fertilizers, pesticides, chemical and industrial materials that we use on our soil to protect our crops and other things. Ultimately, all these materials, these chemicals, they go into the soil, and as a result, they move down in the groundwater, and as a result, we have the problem of groundwater contamination. Geological work of groundwater. Groundwater dissolves rocks, and that is very important, as mostly in carbonate rocks, it dissolves them efficiently. And you can see that in many parts of the world, if you see the Balochistan province, where we have more carbonate rock as a reservoir for water, and as a result of that, we have the formation of large pore spaces and large porosity in those areas, and as a result, we have the formation of a karst topography. Karst topography is a set of features that is developed by the dissolving, eroding action of groundwater. Groundwater, it keeps on flowing and it keeps on forming various features: irregular terrain, sinkholes, sinks, and striking lack of surface drainage. You don't see streams of the surface; you see just streams on the subsurface. So here is a one illustration that indicates the formation of karst topography, and you can see there are different stages here: stage number A, B, and C. In stage number A, you just see the water table, and there are some sinkholes. Sinkholes are just like rounded depressions, and sometimes they cause various problems to the buildings, especially in Saudi Arabia, eastern part of Saudi Arabia. And similarly, we have there is one stream that is sinking. It's just like disappearing stream. That stream doesn't disappear, it just goes to the subsurface, and as the valley is enlarged due to the action of water, and the water, you see, it starts eroding the carbonate rock and the water table. You can see there is a solution valley, there are some springs, and a large cave system and cavern system is normally developed in these type of environments. So, well, that's all for karst topography and the features that groundwater can form.